can of course look at the video recording later on. All right, so the volumetric analysis and the redox reaction. So before I start, let me just inform you in advance that redox reaction sometimes it can be confusing. All right, so we need to pay attention to the terms of the process that is happening. There will be few terms we will be introduced to, will be exposed to, and then these terms means very similar. I mean, it sounds very similar, but it means very different thing. Okay, so let's go and see what we are going to learn. That is the oxidant and reductant, how this oxidant and reductant, which one is going through oxidation and reduction, and then oxidant, reductant, oxidizing agent, reducing agent, all those things. So oxidation number, actually, it will inform us which one is oxidant and which is reductant and which one experienced oxidation and otherwise. So we have to be careful on this oxidation number, and then we will learn how to assign these oxidation reduction numbers to these elements or species, chemical species, of course. And balance the half reaction. Then we will balance two half reaction, make it a full reaction. Later on, we'll see that. Stoichiometry calculation by this redox reaction. Through the stoichiometry calculation, we can find out the full reaction. We can actually calculate the numerical analysis through this redox reaction, just like the other non-redox reaction as well. So yeah, this is another aspect we will be learning it. So what is a redox reaction? Yesterday I was talking about it in the class on the lab, that redox reaction, we just need to remember this mnemonic thing, that's oil and rig, and that is very important, right? And who cannot recall or who cannot remember these two terms, oil rig, right? Oil rig. You know that if we look at the oil, I mean petroleum, the extraction from the sea, some of the petroleum extraction facilities in the sea, at the sea, and there is some platform like on the sea, and it has long legs which is embedded into the sea, right? Which is embedded. This is the water level, and it the platform is quite higher than the water sea level, and then is very big facility. Helicopter can land on that. So this is the rig, right? And we extract oil from here. So just remember, it's nothing to do with this lecture today, but just for you to remember this thing, I draw this thing. I don't know whether I should draw it. I hope I thought that it will be helpful for you to remember. So oil and rig. Oil is oxidation is losing. Oxidation is losing of electron. Of course, I mean oxidation is losing. If we just say oxidation is losing, what is losing? I mean, what else can be lost in a chemical reaction? Of course, an electron. So oxidation is losing of an electron or electrons, and reduction is gaining that electron. So from there, from this definition, we understand that oxidation and reduction goes in hand, right? Because the electrons is going away, it should have been taken up by someone else. Otherwise, the electrons, what it's doing, it cannot stay alone in the system. So when there is an oxidation, there must be a reduction going on in the system. Oxidation reduction goes simultaneously, and oxidation is losing of electron, and reduction is gaining of an electron. And also the oxidation number. What is the oxidation number? We are going to the next slide. But oxidation reaction involves an increasing of oxidation number. Just remember that in the oxidation number will increase if there is an oxidation going on there, and reduction means it will reduce or decrease the oxidation number. So we understand from the reduction that oxidation number will reduce. For oxidation, it will increase, right? So what is the oxidation number then? For any chemical, let's say HCl, we are very familiar to this chemical HCl or sodium hydroxide. Maybe it is familiar to you. Who doesn't know what is sodium hydroxide? NaOH or HCl. Who doesn't know? Anybody here doesn't know what is HCl and sodium hydroxide? I bet everyone. So when we write this it is a neutral molecule, neutral molecule. That means it does not carry any charge, right? It does not carry any charge. Sodium hydroxide as well does not carry any charge, but when they're associated together, hydrogen become positive and chloride become negative. So that is how this positive and negative charge was cancelled each other, and that's how they become neutral, zero charge. Otherwise, if we break it down, hydrogen will become positive charge and chlorine will become negative charge, right? Same goes for sodium hydroxide. Sodium is positively charged, hydroxyl is negative charge. But when they are together, they are neutral. So that is, they are not carrying any charge. So this is called a neutral state. Right. So this positive and negative charge, this is the oxidation state for this element or for this ion, for this element. At this stage, it is the oxidation state. So there are some rules for oxidation determining the number, that is free elements, all the free elements that you look on the periodic table, all the free elements, it has a zero charge oxidation state. Whether it says chlorine or oxygen or fluorine or lithium or sodium, whatever you look at on the periodic table, it is carrying a zero charge oxidation state. Zero. All right. They are not. That means it does not have an oxidation state. Right. It's neutral. Ionic compounds, just like I say that sodium chloride, right? Sodium hydroxide, calcium fluoride, they are not, in their compound, the whole compound is neutral, but in their compound, they are not neutral. They are with some kind of charges, positive or negative, positive 2 plus negative. So this way they are combined, and thus these different charges cancels each other, and then it becomes zero charge, neutral, right? And how do I know that sodium is positive 1 and chlorine is positive -1 and calcium is positive 2, fluorine is -1? How do I know that? Well, you look at the periodic table. All right. On the periodic table, which is group 1 will carry positive 1 charge. Group 2 carry positive 2 charge, and so on. All the metals, they will be positive charge. All the non-metals, they will be negative charge. All right. And then there are some definitive charge for some elements, like fluorine will always be -1. Fluorine will always be -1. Oxygen will always be -2, right? There's always been -2, with some exception, like hydrogen peroxide. Oxygen in hydrogen peroxide is -1 charge, all right? Is -1 charge. And then fluorine is, so hydrogen is always positive, except for the group 1 element, like lithium hydride, sodium hydride, potassium hydride. When they are in that form, hydrogen is negative in that case. Only this is the exception, group 1 element. You look at the periodic table, group 1 element, sodium, lithium, sodium, potassium, all of them, if they are associated with hydrogen, in that case, hydrogen will be -1. But the group 1 element will be positive 1, right? In any other case, hydrogen is positive 1. So these two are exceptions. There are some other exceptions, but it is not applicable here for us to know. It will be good for us to know this much. Sum of the oxidation is number equal to charge of the molecular ion, that is 0. In the neutral molecule, just now, before I was starting, I said that HCl is 0, sodium hydroxide is 0 as well. But for charged ion, right, like magnesium tetroxide, it is charged, so it is having 1 -0, right? It is having a negative 0. Okay. Oh, right. Good. So it is having -1, negative charge. That means -1. That is why it is just shown a negative charge, not a -1 or 2. It is shown. It is zero. I mean -1. The whole molecule, the whole ion is carrying a -1 charge. All right. So how do I find magnesium charge then from here? Well, if I write it in this form, let's say that magnesium, sorry, manganese, not magnesium, manganese tetroxide, -1, right? So let's say that this is, we do not know manganese how much. We just put it is positive X. Of course, it will be positive because oxygen is there. Oxygen will be negative. Oxygen is more electronegative. So it will be negative. And we know that oxygen is -2. It is not within, it is not hydrogen peroxide, so it's no exception. It will be -2. And there are 4 atoms of oxygen here, right? 4 atoms of oxygen here. So -2 times 4 is equal to 8. So positive X plus -2 times 4, right? 4 oxygen atoms, which is equal to -1. Because the whole charge, this small, I mean, ion is carrying is 1 negative charge. That one is here, that way I show. So it is equal to the -1 charge. So if I equate this equation, how much oxidation state I will find for manganese is X equal to +7, right? X equal to +7. So this is the oxidation state at this specific state of this element, ion. For magnesium is carrying +7 charge, oxidation state. Yeah, it's a charge for this oxidation state, but charge and oxidation state is different thing. But for this case, okay, I don't want to confuse you. Just want to say that the oxidation state is plus +7 for manganese for this case. All right. Any question here? Everybody understand this thing, what I'm talking? Oxidation state. For manganese oxide, manganese is +7 for this case, right? Okay. So can you hear me clearly, or is it too much of can you hear me clearly, or is it too much of the? Okay, good. Thank you. Just hold on 1 second. Okay. Good. Probably swimmer is closed today, so bandwidth is not shared, and I'm getting the full access of it. Let me know if it is lagging, then I can turn off my camera, probably. So it will not be a problem for you to get. Okay, so yeah. Now, all right. So now, as we have understood how to find out the oxidation state, how do let's find out the oxidation state for some of the molecules here, for some of the compounds here. So nitric acid, carbonate ion, and then F2O difluoroxide, which will be nitric acid, right? So the total charge is 0 because it is not shown any charge here. It is not shown any negative or any positive or nothing, right? Okay. Okay, so it is not shown any charges here. So since it is not showing any charges here, so we know that it is a 0 charge. It is carrying total charge is 0. If total charge is 0, Then oxidation state for nitrogen. Nitrogen, let's say it is X, just like the one that I do. So nitrogen is negative. So it will be positive or negative X. Let's say that oxygen, of course, is -2. Hydrogen is also positive X, +1, sorry, +1 hydrogen, and oxygen is -2. So -2 times 3, and total is 0, right? So of course, N has to be positive in this case. Otherwise, it doesn't become equal to 0. So X is +5, and that is how only we can make it total. The molecule become, the total charge becomes 0. Same goes for carbonate ion. Carbonate is carrying the total charge of -2. So if we want to find out the carbon oxidation state of carbon, of course, oxygen is -2, right? -2, and then times 3. There are 3 oxygen atoms here. So negative times 2 is negative, 6. And their total charge is -2. So X, that means carbon oxidation state is 4. So in this way, we can find out the difluoroxide is also will be positive X, a +2. Oxygen is, in this case, is +2. That means oxygen become positive. So this is another exception for oxygen, that it will be, because fluorine is much more electronegative. It can attract electron much more strongly than oxygen does. So that is why it is +2. So main group elements you have to find out. This is for your homework. Plus try to do, how do you find out the oxidation state for magnesium carbonate? What is the oxidation of magnesium, the barium, calcium, all those things, right? Now, another, interesting thing is, we see that hydrogen, for oxygen, we always consider it is -2, right? But here we see it is +2. So that means oxidation state is nothing universal. It is not very like it has to be always the same thing. It's not. Sometimes it changes. And it changes mostly for the transition metal elements, right? The transition metal elements, that means that we see in the periodic table from the elements, the metals that we see in that periodic table, that is called the transition metal element. And metals, so they have variation of the oxidation state, and their variation of oxidation state helps us to, for the material to be different. What is, one visual example of this, that vanadium oxide, all right? Vanadium has a very different, what is that vanadium? Vanadium has a many different oxidation state, 2 + 2 + 3 + 4 + 5. 4 different oxidation state. Chromium has even more. Manganese has even higher number, although this 6 and 7, that is extreme, but this +2 + 3 + 4 + 6, these are common. Most of the time it occurs. Okay, iron has quite many. Cobalt, nickel, copper, zinc, they all have different oxidation state. So if the oxidation state changes, right? If the oxidation state changes, their color is changing. The color that we see, perceive our eyes, it is changing, right? Why it is so? Because when, what is that? Why do we see the different color? It is the absorption and reflection of the light, and light absorbs or reflected depends on the electron it excited. Because of the impedance of the light, right? The electron get excited and jumps from one stage to another stage. I think you have seen it in the what do you call it, high school. So this is a nucleus, this is orbital, one electron is here, and then when we are putting some light, UV light, let's say, the electron is getting excited and jumps to the next stage, become excited and jumps to the next orbital, and then after the excitement gone or the energy is lost, the electron is slowly coming back to the original position. When it's coming back to original position, it is emitting the energy it had, right? That energy we are looking at, seeing as a light. This is a simple explanation. So that is why, so since it has different oxidation state means it has different number of electrons outer shell of the atom for that molecule, element, right? For that element, it has a different number of electrons, outer shell, and then different number of, since different number of electrons, so the orbital number changes or orbital energy changes and different energy it absorbs. Sometimes it needs a very high energy, sometimes it needs just enough energy for it to be excited. So it depends on the different energy, we see different colors of the transition state metals. All right, so transition state elements. All right, so this is one the visual explanation or example of what the oxidation state does for it. So this oxidation state not only changes the color, but it also helps us to understand the nomenclature or the name of the element compounds. Like iron here is +2, right? Iron is +2 here because chlorine is all -1, and then there is two atoms of chlorine, so it will be -2. So +2 is iron. So that is why it will be, by this way, it will be neutralized and it will be total charge is 0. So that means iron is having two oxidation state, which is given here. This is the nomenclature we do. Iron chloride. If you just say iron chloride, we do not know whether it is iron 3 chloride or iron 2 chloride. So you have to indicate whether the oxidation state of iron is 2 or 3, because these two chemicals are different. Their color is different. Their chemical property is different. Their reactions are different. All of the things different. So this is how we oxidation numbers and helps us to understand what type of reaction or the compound it is. Same goes for mercury iodide, right? So mercury iodide here, mercury and iodine, let's say that mercury and then iodine, and then again mercury, right? So this way it is Aaron. So that means 1:1, 1 mercury, 1 iodine, 1 mercury, 1 iodine. So that is why mercury and iodine, or maybe we can see the oxidation state, it is +1, it is -1. So that is how it is only one oxidation state. But for this case, it is mercury 2, +2, sorry. So this is iodine, it is -1, but times 2. So that is how it is neutralized. So this is, it will be 2 mercury iodide. Lead oxide. Here, oxygen is, lead is +2, oxygen is -2, right? So this is and same goes for oxygen is -2 times 2 is equal to 4. So it should be +4 lead. So this 4 is here, right? So this is, so redox reaction not only do the color, as we have already seen that it shows us color, right? So scientists came up with the idea that, okay, if it shows the different color, then why don't we make it fireworks? And it does. It helps us, right? So you see that magnesium, all the fireworks from now on, you'll see it is just a changes of oxidation state of different elements. Of course, the fiery elements, but it changes the different oxidation state at that moment, from becoming a white color to reddish color, then a greenish color. All those are because of this oxidation state changing due to the high heat. When you light up, right, it has a higher energy, so it changes the oxidation state of this. So oxidation for magnesium atom loses 2 electron to become magnesium ion. So can anybody tell me Sorry. Can anybody tell me what is happening here? Magnesium is becoming magnesium 2 positive, whether it is a oxidation or reduction reaction. Faster. Counting once. Counting twice. Okay, Ian, thank you for the answer. Anyone else? No, it is oxidation. Oxidation is losing of electron. Remember oil, OIL. Oil is oxidation is losing. So oxidation is happening here. Magnesium is losing 2 electrons. All right. At the same time, oxygen, since it is more electronegative, it will take up 2 electrons and it will become, the reduction will happen there. Right. So this is the oxidation reaction is going on, and the overall reaction is 2 magnesium oxygen. You just remember this reaction, right? We will later use this thing as well. Magnesium oxygen and magnesium oxide is happening. So you see that magnesium, it is losing 2 electrons, and this oxygen is taking these 2 electrons as well. Sorry, oxygen is taking that 2 electrons as well. Of course, there are 2 atoms, so 4 electron has to be taken. So to get the 4 electron, I have to oxidize 2 magnesium so that I will get 2 magnesium ion, of course, and then 4 electrons, right? So this is how, sorry, 4 electrons are coming, and these 4 electrons are then being useful here for oxygen to take up. So this is the full reaction at the end. All right. So oxidant and reductant, oxidation reduction, we have already learned. Oxidation is losing of electron. Reduction is gaining of electron. Now another 2 terms. Just remember another 2 terms. We will need to remember: oxidant and reductant. Right. Oxidant. Which one is causing the oxidation, but it become reduced itself? Okay. Oxidant is oxidizing someone else, but it is getting reduced by itself. Just like you borrow money from your father, you get richer, your father becomes poorer. I don't know whether it's a good example or not, but anyway, I hope that you will remember. So oxidant is experiencing decrease in oxidation number. That means it is reducing itself, but it is causing someone else to increase their oxidation state, oxidation number. The opposite is true for reductant, right? So now identify the oxidant and reductant. For this case, we know that oxidation reduction reaction is going on here. Magnesium oxygen, right? So magnesium and oxygen is happening here. Magnesium is being oxidized, right? It is losing the electron. The oxidation is going on. But what is an oxidant here? Who is causing the oxidation? We know the oxidant is decrease in oxidation number. Oxidant will experience itself decrease in oxidation number. Who is experiencing oxidation number, decrease oxidation. Here oxygen is 0, oxidation state. Magnesium is also 0, right? It is not shown, that is why we know that is 0. But in this case, oxygen become -2 and magnesium becomes +2. So magnesium increases, +2 increases, and oxygen -2, that means it decreases. So it is an oxidant. It is causing this magnesium to become oxidized. So this is oxidant, and then the other is a reductant. All right. So balancing, how do we use this type of reaction to balance the half reactions? Balance the oxidation reduction reactions, right? Magnesium we have already seen this one. I don't think that we don't need to talk much, but nitrate ion is becoming dinitrogen oxide in acidic condition. This is very important. Why? We will tell you later. In acidic condition as well. Magnesium is becoming magnesium oxygen, and nitrate ion becomes dinitrogen oxide, and chromium chromate ion becomes chromate ion. Yeah. Okay. So so how do we balance this equation? Now we already have seen, or we already know, that oxidation reduction is happening first. Either oxidation is happening and then reduction, or you can say that no, reduction is happening, but it doesn't matter, because there is oxidation is happening and reduction is happening, right? So we divide it to oxidation and reduction, half and half, like half reaction. That means oxidation in a half part, another half is reduction is happening. So we have to the rule of balancing that all elements we should balance except hydrogen and oxygen. All right. So hydrogen and oxygen, we do not need to balance at the very beginning. Of course, we need to balance it, but later on. Hydrogen we will balance by using water. Right. Sorry, oxygen we will use by adding water to the product side. Because oxygen will produce water. Of course, we need hydrogen for that, but this hydrogen we will see where the hydrogen is coming from. Oxygen will produce water. How? One oxygen can produce one water molecule, H2O, by taking two hydrogen atoms. Right? So this is how water will produce from oxygen. And then balance the hydrogen using hydrogen ion in acidic condition. So when it is an acidic condition, this we can just borrow the hydrogen ion or proton. In this case, we see, because we know that it is an acidic condition means there is a lot of hydrogen ion. We don't have to worry where this hydrogen is coming from, because acidic condition means a lot of hydrogen ion already available there. So we can just balance this hydrogen ion based on this acidic condition. So, okay, acidic condition, hydrogen ion we are getting. Balance the charge using electron. Each electron carry -1 charge. Okay, each electron will be equal to -1 charge. -1 charge. All right. So electron is shown in this way. Electron is shown in this way. -1 charge it will carry. So we have to balance on both sides. The number of electrons are same. All right, so go to the number one solution. That is, where is it? Magnesium. Magnesium. Okay, hold on. Okay, so magnesium, it is okay. This is oxidation is going on, right? Magnesium is losing up electron. These 2 electrons it is losing, right? And then one magnesium ion is losing 2 electrons, but for oxygen, 1 atom of oxygen needs 2 electrons. So there are 2 atoms of oxygen here. 2 atoms of oxygen. So I need 4 electrons, as I said. So I have to multiply. I mean, when I balance, this equation has not been shown in balanced, but it was just now I showed it. So if I want to balance it, I need to multiply it with 2 so that I will get 2 magnesium and 4 electrons here. These 4 electrons will be, it is here, right? It is here, the 4 electrons. So that I will have 2 magnesium plus oxygen. That means 2 magnesium ion and oxygen atoms. Ions is being produced. All right. So this is how will be the magnesium oxide. Sorry, magnesium oxide will be produced. So this is how the reaction is balanced. It becomes inverse. Oh, okay. Nitrate ion. nitrate ion is producing dinitrogen oxygen. So from here, we look to this product, we see what is lost or what is gained here. We see that one electron is lost because on the product side, there's no indication that there is an electron or anything. So one electron is lost. But for this case, I see that two nitrogen atoms is still the same number of two can be equalize that two nitrogen both sides. And here, how many oxygen can tell me how many oxygen do I have here? Atom, or how many oxygen atom is lost? Can anyone tell me? Anybody? How many oxygen atoms are lost or lacking or anything? Two? Thank you for the answer, but it is not correct. Anyone wants Ahmed Green? 3 and then 2. No, not correct. 3 times 2. So how many oxygen atoms are there? Can you tell me how many oxygen? So 2 times NO, right? We need to understand this because I will not go through others. So 2 times NO3 and -1. So there are 2 nitrogen here, 2 nitrogen, and then plus oxygen, 3 atoms of oxygen times 2 molecules, 3 times of oxygen atom. So it will be 3 times to 6 oxygen atoms, plus of course 2 electrons, because of one each nitrate ion carry one negative charge. So 2 of them will carry 2 electrons, right? Have to be 2 electrons. So I see that I have 6 oxygen here. It's not 60, yeah, it is 6 oxygen. All right, it is 6 oxygen. So I have 6 oxygen on the left side, but on the right side, I have 2 nitrogen, that is good, but I have only 1 oxygen. Where the another 5 oxygen then? I have another 5 oxygen and 2 negative charge. Don't remember, forget 2 electron. So this 5 oxygen can produce 5 molecules of water. If I can produce, I will see that 5 molecule or 5 oxygen is producing 5 molecules. So this is how I can balance. And now we see that the number of elements or atoms are balanced. 2 nitrogen plus 1 and the 5 oxygen plus 1, 6, already 6 oxygen. And then you can say, okay, where did you get the 10 hydrogen? 5 times 2, right? 10 hydrogen atoms. Where did you get it? Okay, it is in acidic condition. So I do not have to bother with this hydrogen because the acidic medium, remember yesterday you added hydrogen, sulfuric acid to make it an oxygen, acidic environment, right? Make it an acidic environment. So this acid hydrogen ion is coming from that acid. I have plenty of hydrogen ion in there. I don't have to bother. So that means I have a lot of hydrogen ion. I can just take it as I need it. So I took it as I need. So 10 hydrogen atom, I took 10 hydrogen atom. That is proton. So now it is balanced again, balancing the hydrogen using the. But now again, we have to balance the charge because we see that here 2 electrons because of 2, and then here's 10 positive charge, right? 10 positive charge and 2 negative charge. So altogether is 8 positive charge is still excess I am using here. Electron, or sorry, the charge, you must balance the charge at the end. If you want to balance the charge at the beginning, you will be lost. So balance the charge at the end. So, oh my God, I have to finish this. What? Another 20. Okay, so 8 electron excess. There's 8 electrons I am using just as I need it on the left side. Don't ask me where you get it from, because it is an acidic medium. This hydrogen, when hydrogen ion is produced, a lot of other electrons will be balanced from where the hydrogen is coming from. Maybe it is coming from HCl, maybe H2SO4. This SO4 will provide this electron, right? So yeah, so we don't have to bother too much, just have to balance where this electron is coming from. This electron, and now I added it, and on the both side, now I see that electrons are balanced, both sides. So zero electron on this. So this electron is charged. Same goes for this chromate, Cr2O7O2 negative, and then it becomes chromium 3 ion. So same thing, we have lost here 7 oxygen. That means 7 water molecule can be produced, and here we have produced 7 water. 7 water means 14 hydrogen. So 14 hydrogen, because it's acidic medium, I just took it. 14 hydrogen from considering it is acidic medium, 14 hydrogen atoms, and then it is balanced. Only the charge I need to balance. This charge is 6 electron was excess I needed. So I needed 6 excess electron, and it's balanced in this way. Okay, so example 3, overall ionic equations. Now, when we are saying that overall, it is only, it asked you to balance the half reactions, right? Half reaction. But overall ionic reaction, when I balanced, I'm also, of course, I have to consider the atoms, and then hydrogen, oxygen, and now again, the electrons, where it is coming from. Overall ionic equation. So one of them is iron and manganese oxide. So they are reacting and producing iron and manganese. So can anyone tell me where is oxidation and where is reduction happening? Where is oxidation, where is reduction happening for this case? Iron becoming positive 3 from 2, so it become oxidized, right? So the other way, of course, manganese become reduced. It's easier to know, understand. So iron become oxidized, manganese reduced. So in this case, we have to balance the whole thing. Iron is oxidized, so it produces 3. So what happens? I have to, I mean, where it removed one, it liberated one electron from here, right? Liberated one electron, that is how it becomes positive 3. So I have to write that electron as well. I have to indicate that the one electron has been removed or liberated. And then manganese and oxide and hydrogen ion. Sorry, where is that? Okay, manganese, and then it is being only manganese. What happens to these 4 oxygen atoms? 4 oxygen atom means it will produce 4 water molecule. All right, it will produce 4 water molecule, and then this 4 water we have to add it. So, and to produce this 4 water molecule, I have to add 4 hydrogen as well. I'm adding this for because it's an acidic medium, right? So now we see that I have to balance the electron. So from here, I see that 1 electron is coming from 1 ion atom, right? 1 ion atom, or ion is 1 electron is coming, but I need 5 electrons. And I do not know who else is giving, because consider that there is nothing else, only iron and manganese oxide in the solution. Who else is giving this ion? So I have to make sure that I have this number of electrons together. So I have to multiply this ion with 5 so that I have 5 electrons. And then only this 5 electron will be balanced. This is cancelled out on the both side, and the rest is here. So 5 iron and magnesium oxide, 8 hydrogen and 5 electrons on the left, and then 5 iron is produced, 5 electron is produced. You can, if you want to be more sure, you can just put one negative charge, no problem. Or if you don't, it's okay, no problem as well. And then manganese and water, right? And at the end, plus just remove this ion so that it will be the total overall ionic equation. This is the ionic equation, overall ionic, balanced ionic equation. Everything is balanced if you look at it. All right. Okay, so this is the analytical chemistry and redox reaction. So redox titration, with the help of this redox reaction, we can do the redox titration just like yesterday we have done it. One of the very helpful thing or useful thing is doing the titration, using the redox titration for alcohol to know the quantity of alcohol. All right, because alcohol is a big business in the Western world, including Malaysia, because the consumption of alcohol is quite high here. So we need, scientists, most of the time, those industries, they need to, time to time, quality control of the alcohol for the alcoholic drink, the hard drinks. How do they do that? So ethanol and then sulfur dioxide in the wine, fruit juice, vitamin C. It also can be quantified using this titration analysis, this redox titration, and bleach, hypochlorite ion, we have seen already yesterday. Also, hair bleach. Sometimes we know our students also do a lot of bleaching every day. No, not every day. During for the hair, they do a lot of bleaching. Okay, so yeah, so those things we can find out how much is the quantity of all those compound here. Potassium permanganate, right? It reacts with hydrogen peroxide, and then it can be hydrogen peroxide reacts with this, and hydrogen peroxide loses this. What is that called? That Chlorex. What do you use it for? Okay, I forgot anyway. So anyway, for this reaction, manganese tetroxide, hydrogen peroxide, and then it's producing manganese and water, and of course oxygen gas. Hydrogen peroxide is used for what? Anybody? Why do you use the bleach? The same purpose. Disinfection. Disinfectant. As a disinfectant, we use it, or the color removal. Yeah, but there is a name for this actually. What do you call it? Bleaching. Is also used as a bleaching agent, right? Hydrogen peroxide, and it's very strong bleaching agent actually. So and oxidizer. Anyway, so this is, we are using, let's say that for this purpose, manganese oxide is used in hydrogen peroxide and produces manganese and water. So 25 milliliter of 0.202 molar potassium permanganate solution. This permanganate ion, it is coming from potassium permanganate actually, right? It is coming from potassium permanganate. Is reduced by 20 milliliter of hydrogen peroxide solution. What is the concentration of hydrogen peroxide, right? So we need to know how it has been reduced. Potassium permanganate is so oxidizing agent. It is so strong oxidizing agent that hydrogen peroxide is an oxidant as well, but it is being used as, it is to this respect, it become a reducing agent now. So now potassium permanganate is used, hydrogen peroxide, so 25 milliliter, 0.2 molar. We can find it or not. It's just like the C1 C1 V1 C2 V2 from this reaction, the titration we will be doing it, right? So yeah, magnesium tetroxide, we need to see that who is having the oxidation or reduction. So positive 7, it becomes positive 2, so it becomes reduced, right? The oxidation state reduced, number of oxidation number reduction happen. So this is a oxidation state. 0.7 to positive 7 to positive 2 it becomes. And then hydrogen peroxide, oxygen is negative 1 it was, but it becomes 0. It was also reduced. And hydrogen it was 1, 1, 1 is always no change. All right. So from here, oxygen, it was negative. It becomes increased to was 0, right? It is increased to 0. So oxidation number increases, and it's positive 7. It reduces to positive 2. That means it's reduced here. So it's an oxidant. It used as an oxidant, and hydrogen peroxide as a reductant in this way. Now, of course, we have to find out the number of moles for manganese tetroxide, and then from there we see this. So 2:5 reaction. 2:5 reaction, right? 2 moles of manganese tetroxide is reduced by the 5 moles of hydrogen peroxide. So from there, N equals C into V. From there, we can find a concentration of it. One example, another example. How many more to go? Okay, we're almost done. All right. So 10 milliliter sample of white wine was placed in a volumetric flask, and then water was added to make it 100 milliliters. So you know that it is 10 times dilution. The sample of wine was 10 times dilution. Then 20 milliliter aliquot of diluted wine were titrated against 0.1 molar acidified potassium dichromate. Acidified potassium dichromate. Why? Because I need this hydrogen ion to produce water. Otherwise, the reaction will not happen. So acidified means we have to put sulfuric acid, or maybe HCl can be. So now, what is that? That 20 milliliter aliquot of diluted wine were then titrated against 0.1 molar acidified potassium dichromate. 0.1 molar dichromate, and it was 24.61 milliliter was needed. So from there, we see the constant number of moles, N equals C into V, right? N equals the same thing. Why? I don't know why I'm talking again, but anyway, I will keep talking until you say that, okay, I am bored. I understand it very good. No need to talk. Okay, but until then, I'll keep talking. So number of moles is concentration is 0.1 molar, this 0.1 molar, and volume is 24.61 milliliter. That means 0.02461. So from there, we can find out the constant number of moles. It is N, not anything else. It's N. So number of moles of potassium dichromate we find, and then the same number of moles we have to see the constant. Equation for this. How the equation is going on. Of course, in the wine, what we are titrating is ethanol. It is the main ingredient. Is ethanol. So we are titrating it, and this is 2:3 reaction. So we know the number of moles of chromate from N equals C into V just now. And then from there, we can equate it 2:3 reactions. So number of moles is 3/2 times the chromate number of moles. So from there, we can find it is 0.00369 number of moles. And then this is the number of moles, and the concentration of ethanol in the wine is N over V, the number of moles over the volume. Volume we took, of course, it is 20 milliliter, and then we diluted. We have to multiply with the dilution factor, which was 10 times dilution factor. So concentration was found to be 1.85 molar in that. 1.85 molar of ethanol. How much? What is the mass? 1.85 molar. What is the mass? Ethanol is 46 gram per mole, right? Gram per mole. So number of moles we find in the gram, how many grams in it, and then it is in 1 liter. Of course, the gram, and it is liter. So gram per liter you can say, or if you have to find that weight volume by volume. If the question is asking you volume by volume, then gram per liter is not acceptable anymore. You have to convert it to liter, because to multiply with the density and convert it to liter or milliliter, and then convert this whole thing in a milliliter, or vice versa. You can convert to liter as well. It is also good. So this is volume by volume, as long as both of these numerator and denominator are the same unit. You are expressing the same unit, liter, or gram. So volume, if it is weight by weight, then gram by gram would be good. But since this is volume by volume, you have to convert it to milliliter or liter by liter. Is that okay, everybody? Is that okay? I'm guessing that it is okay. All right. So another way, if somebody is consuming this alcohol, of course I don't know. I mean, it is only for recreation purpose, people call it. But as a chemist, I know that you are poisoning your brain, because alcohol, why do you do the hallucination? Why the hallucination occur, or why people do crazy thing? Because it reduces the oxygen to your brain, and which was very important during this COVID. We know that you have to have the oxygen. People were suffering for cannot breathe. So the brain cannot process without oxygen. The brain cannot process your information, or it cannot take the decision. So it reduces the oxygen flow to your brain, and you see the hallucination. You do not have the sense what you're doing, all the crazy thing people do, and that is why it is not allowed to drink under, drive under this influence. And if you do, people will, the police will catch you. Used to do the breath analyzer, and this is instrument, very strong instrument. You have to breathe it. So this is alcohol sensor. It is in that breath analyzer. It is actually working as a cell, fuel cell, different kind of fuel cell actually. It's alcohol cell, but the fuel cell actually is a very good research nowadays is going on, and then for the energy crisis. Oh, so many of you are doing the renewable energy, right? So some of probably you can read about the fuel cell, because in future the fuel cell is going to be a good game changer, probably, hopefully. And there are quite a much of research is going on that. So if you go to the later on higher studies, you will know more. Just to tell you that fuel cell is a interesting topic nowadays in the research. So how does it work? The alcohol breath analyzer. So this one, it will in the anode, it is oxidizing. The alcohol becomes oxidized and produces electron, which is then taken up at the cathode. There will be some other reagent inside already. So that is how, when the electrons is passing from one anode to cathode, the electricity is, the circuit is complete, and then the light will go on, the red light, right? And that if the red light goes on, then you know that you're doomed, right? So it is not, I don't know why people will do that, which is bad, which is killing them softly, and also which is very injurious to health. There are a lot of controversy about it. Anyway, okay, so now this is how I finish the lecture. I'll move on to this tutorial, the example problem. I'll not go through all. I'll go just on 3 of them. But before I do you have any question? Do you have any question? Anybody wants to ask any question? Is there any question anybody want to ask? No, no question. That is good. No question. Then what I will do is I'll take 5 minutes break. 5 minutes break. And then during this 5 minutes, please go to menti.com faster. Menti.com. And I have quite many actually for this redox reaction. I want to do few of them. Okay, menti.com, and then use the code. Okay, I just copy the link. Yeah, it's better, I think. I copy the link and put it here. All right, menti.com. Go there. Vote it faster. I'll just give you a few seconds only. By the time I make some tea for myself. Do it faster. Okay, so 15 students has voted. Let's see how many of sodium is 6 of us, sodium 5 of us. Why 15 student? I can only see 6 of us here. How come 15 student is voted? Okay, 5 says sodium, 5 says no, 6 says sodium, 5 says sulfur, and 4 says iodine. So let's see. Sodium iodine is from 0 is getting -1. Sodium here was +1, is still +1. So iodine is getting oxidized or reduced. Iodine is getting reduced because from 0 to -1. For sulfur, however, is getting oxidized because it is, if we calculate it, you will see that it is here is +2, is becoming +4 probably. Yeah, something you need to calculate it so that we will see. Okay, so this is one. Another one, Menti question I have. Okay, I need to remove it first from here. Another question is, manganese, yeah, this one. Right, go to menti.com. You are still there. I'm hope. And then this is the another one. Okay. Yeah, vote it faster. Which one is the, which are the correct products formed by this reaction? That means which reaction is correct? A, B, or C? By the way, this type of question, I mean, multiple choice question will be during your midterm, midterm, what do you call it, exam, right? The midterm exam, which will be in week 7, I believe, or week 8. I think you already have seen the timetable or the announcement. Yeah, so faster, and just one minute I can give you. Faster, only 2 students has voted. I need more. 30 seconds. For another 3. I can see only 3 students voted. Three, 2, 1, gone. Okay, so the correct answer should be B, right? Most of us has voted for B. That's very good. So it is very good that you have voted for B. Who haven't voted for B, you now see, you now know that the correct answer, and you have also tried. Thank you for trying, and I hope that you can by making mistake we learn, all right? Oh, so the question, there is a question here. It says Ahmed Karim in tutorial week. What is in tutorial week? Ian can explain why it is B. All right. So which are the correct product formed by this reaction? Manganese oxide and chromium hydroxide, right? So manganese hydroxide, it will be formed because manganese will have a 2 positive charge, right? And then chromium ion, chromate ion is being formed. But for this case A, you see where is the hydrogen? It's still manganese tetroxide chromate, but where is the hydrogen? No hydrogen. Same thing goes for C. There's no hydrogen, traces of hydrogen. That means total is imbalanced. I mean, atoms are imbalanced, at least. And that is B is only the balanced one. Or at least for the atoms, right? For A and C, hydrogen is missing. That is why it is not. Yes. So, oh yeah. Okay. Yes. Yes. In the tutorial week. Yes, the exam will be in the tutorial week. All right. So I move to the tutorial now. the word, problem for us to see what's the problem that we should be learning. What the problem? Okay, so let me share the questions with you. All right, so here I will not go through all, but some of them. Self-testing question, the answer has been given as usual, but I'll go through some of the explanation here. That which one of the reaction of hydrochloric acid below is a redox reaction? Which one of the reactions of hydrochloric acid below is a that means not all are redox reaction. Why? Because they have not changed the oxidation state. First, second, probably they have changed the elements or the molecules has been changed, but the oxidation state is the same. So for this case, for A, HCl and sodium sulfide is H2S and sodium chloride. For this case, I see the sodium is +1, sulfur is -2, hydrogen is +1, and chlorine is -1, right? So I see that hydrogen is still +1, sulfur is -2, sodium is still +1, and chlorine is -1. So it has not been changed. Anything has not been changed. So it is not a redox reaction, right? It's not a redox reaction. Right? For in this way, if we look, we'll see that B is the same thing. It has not changed. Right? C is the same thing. It has not changed. D is the same thing. It has not changed. Anybody wants to say anything? Actually, D has changed from iron 0 to become iron +2. That means it oxidized. Hydrogen +1 to 0. That means hydrogen become reduced. So this is oxidation reduction reaction. So for the rest of this, you have to go through like that so that you will see this is true. Okay, and question 2, it says that which of the following reaction not a redox reaction? Same way, all of them are redox reaction to some extent. One is not. It is a redox reaction because it was 0. It was 0, but now it becomes +1, and this has become -2. So it is a redox reaction. Sodium, it was 0 in there, and it becomes +1. So it is a redox reaction. Lithium, by the way, it was 0. And then hydrogen was +1. And so lithium, it is now +1, and hydroxyl is -1. So it is a redox reaction, it looks, and then which is not a redox reaction, yeah? No, it is, sorry. It is, lithium is +1, and here it is still +1, right? Hydrogen is +1, now oxygen is -2. It is still hydrogen is +1 and oxygen is -2. So it is not a redox reaction. So this is the correct answer. This is not a redox reaction. The rest are redox reaction. In any redox reaction, the substance that undergoes a reduction will what? Of course, it will gain electron, right? And the opposite is true for oxidation. For what is the oxidation number of the element in perchloric acid? Perchloric acid oxidation number. So it does not say anything specifically. So what we'll do is we know that hydrogen is mostly positive unless it is exceptional. Oxygen is mostly negative unless exceptional, but it is not exception. So it will be positive and negative, and there are 4 oxygen atom. And then chloride, it varies. We have seen already that is like the transition element. It also varies quite much. So we can just consider it is +X. And then equate it, we see that it is +7. So hydrogen is +1, or chlorine is +7, and oxygen is -2. So this is A is the correct answer. The transition element, metal vanadium, vanadium exists in a range of different oxidation state. Two vanadium species are vanadium oxide and vanadium tetroxide. So the oxidation state of these species are, what is the oxidation state? So we do not know vanadium, so just consider it's +X, and oxygen is -2, and then equal to +2, because the whole charge it is carrying is +2, right? So is equal to +2. So in this case, vanadium will be +4. It's +4. And in this case, vanadium will be +5. So this is A is the correct answer. The same way we go. Any question? When will you post the answer? I think the answers are posted already. Okay, so please check the canvas. Question 4, question 7, it says that the equation for a reaction that occurs during the extraction ion from iron ore is ferric oxide and carbon monoxide. Carbon monoxide is coke is used to oxidize, to reduce the iron ore to iron. Okay, so iron changes from it was, what is the, it is -6, right? 3 times -2 is -6. So it should be +3. 3 times 2 should be 6. So +3 to 0. It becomes +3 to 0, and oxygen is carbon monoxide. Carbon monoxide is the reductant. It's a reducing agent. Reductant and reducing agent is same thing. Oxidant and oxidizing agent are the same thing. 8. The reaction between iron and nickel sulfate may be represented by the ionic equation. All right, this is the ionic equation. Now, nickel, iron, and nickel iron 2. This reaction is classified as a redox reaction because, of course, the oxidation state is changing. Nickel is becoming reduced, iron is being oxidized. I don't want to go for 9. Question number 10. Which one of the following half reactions is correctly balanced? Anybody? Oh, it's already given the answer, but why? Chlorine, it says that 2 chlorine atom in a chlorine molecule, that is diatomic molecule, right? Chlorine, fluorine, oxygen, nitrogen, iodine, they are diatomic. So bromine, so that chlorine is taken an oxygen become negative. It is not true because there are 2 atoms, so at least 2 electrons should be there, so it is not balanced. Aluminium, there are 3 electrons, right? And then it is becoming aluminium 0, that means electron being reduced, and 3 electron. 3 electron on this side, on right side means this is the product, right? On the right side is the product. That means 3 electron being produced. This is not true. It needs 3 more electron for the aluminium to become aluminium 0. So this 3 electron should be on this side. Actually, where should I write? Okay, 3 electron on this side. Then only it will become this. So it is not correct as well. C, iron has taken 1 electron, becomes iron 2 positive, right? So this is correct because it will take 1 more electron with 3 charge, 3 positive charge. Electron is 1 negative charge. So if it takes 1 negative charge, it will become 2 positive charge. 1 negative charge is gone. So this is the correct one. Same ways it is not true as well. Question number 11. Which statement about water in the following half reaction is correct? Right. So water and 2 electron, hydrogen gas and hydroxide molecule. It is stating. So there are four different, of course, options are given. So here, water is acted as an oxidant only, oxidizing agent, because if we see the oxidation state, hydrogen was +1 in the reactant, but it becomes positive on the, it becomes 0 here. From +1 becomes 0. So it is a reactant as an oxidant only. And this is water also becomes self-ionized, but here it is not showing that hydrogen and oxygen, so it is not correct. This is not correct in this case, but is usually correct. Water becomes self-ionized, but not in this case. Question number 12. Which of the following reaction in the underlined species acting as a reductant? Reductant. So if it is a reductant, what will happen? Right? Reductant means it will reduce someone else, but it itself will be oxidized. Right? It will reduce someone else, but it itself will become oxidized. So underlined species, so copper oxide, it becomes copper. It was +2, becomes 0, so it becomes reduced. So it is an oxidant. That is why it becomes reduced itself. So it is not the correct answer. The oxygen was 0 here, and then it becomes carbon dioxide. Let's say all the oxygen becomes -2. So oxidation state reduce from 0 become negative. So it is also an oxidant. Is not. So in this way, if we go, or you see that all are incorrect, only D is correct, because manganese oxide, right? Manganese was +2, +4 here, and oxygen was -2. Right? So from this +2, 4, it becomes +2. Sorry, +4, it becomes +2. Right? So here it has been reduced. It has been reduced by sulfur dioxide. So sulfur dioxide is acting as an reductant here. All right, and it was 0, but it becomes increased to -2, reduced. So of course the oxygen numbers changes. So here, that is why it is a reductant, which has reduced manganese and oxidized itself. All right, sulfur becomes oxidized. Question number 13. Vitamin C, or ascorbic acid, C6H8O6, is classified as an antioxidant. And that is why we should take vitamin C, citrus fruit as well, lemon, all type of lemons, and veggies, green veggies. They are antioxidant, very good for health. So determine the percentage by mass of vitamin C in a tablet. A student weighed 1 tablet into a conical flask. Remember, just 1 tablet in a conical flask, then crushed it in a deionized water, right? So ground it, pounded it to make it fine powder, and put it in deionized water. The vitamin C solution was then titrated against iodine solution in concentration of 0.1621 mole per liter. Right? The equation of the reaction was as it is. From the equation, we see that it is 1:1 reaction. Very easy for us. Our life become easier in this case. Given the titer was 27 milliliter of the tablet, and the tablet was 1.33 gram. what is the mass percentage of vitamin C in the tablet? So from here we see that titer means iodine solution was 27.40 milliliter, right? And concentration of which is 0.16. So number of moles N equals C into V. Once again, are you bored already about telling me the number of moles and then N equals C into V? If you are bored, then congratulations. All right, so 0.1620 times the volume, that is 27.40. I will convert it to liter, which is in milliliter. So 0.027 2740. Right, so this will be the number of moles. From here, we see that it is the exact same number of moles of vitamin C because 1:1 reaction. Correct? Is 1:1 reaction is 1. So exact same number of moles it will be there. And if we multiply the number of moles, because it will be the same number of moles of vitamin C. Vitamin C. Vitamin C, okay, it's vitamin C, same number of moles. So if we multiply with the molar mass of vitamin C, if you go and check the molar mass of vitamin C, which is, molar mass of vitamin C is what? 176.4, no, 76 gram per mole. 176 gram per mole. Vitamin C molar mass of it, so that we know the mass of it, right? So the mass of it is 0.7812. 0.7812 gram. And this gram is in the whole tablet, right? The tablet was 1.335. So it is in 1.335 gram. So what is the percentage? Times 100%, we will get the percentage of vitamin C in the tablet by this way. Now I'm moving to the question number 14. The concentration of hydrogen peroxide in an antiseptic solution was determined by titration with 0.02 molar potassium permanganate solution. 20 milliliter potassium permanganate solution was diluted in 250 milliliter. Already you know that it is 250 over 20. That means 12.5 times dilution, right? So 20 milliliter was diluted in this, so it is 12.5 times dilution. 5 times dilution factor. And then from there, 20 milliliter aliquots was taken of the diluted solution, was acidified and titrated against the potassium permanganate solution. An average titer of 18.93 milliliter was required for this titration. This average titer, 18.93 milliliter, is what? What is this actually? It's potassium permanganate, right? It's potassium permanganate. And this is the peroxide solution. So this is the potassium permanganate solution was required, which has a concentration of 0.02. So same. So what is the concentration of hydrogen peroxide in the solution? Same way, N equals C into V. Potassium permanganate, we will find N equals C into V. We will find the constant number of moles, 0.02 molar times 18 or 0.01893. 0.02 molar times 0.01893, right? So this is the number of moles of potassium permanganate we required. And then we see there's 5:2 reaction. This is the only trick that we should be careful of. So this is 2:2. So 2 moles of potassium permanganate is required to be neutralized 5 moles of hydrogen peroxide, right? So if I have, let's say, X mole, right? I have X mole of potassium permanganate. How many moles of hydrogen peroxide we will be having? There is a easy way we can do it, that potassium permanganate MnO4 over hydrogen peroxide is 2:5, right? 2 molar of potassium permanganate by 5 molar of hydrogen peroxide. So if I want to know what is the hydrogen peroxide, number of moles of hydrogen peroxide, H2O2, oh, actually it should be number of moles, actually, yeah. This is number of moles, right? It's N, number of moles. So it will be, if we just rearrange this equation in a bit, that I bring this in that side and then hydrogen peroxide in this side. So it will be 5/2 hydrogen peroxide, potassium permanganate, MnO4, number of moles. So here, if we just replace this X by this way, we will find what is the number of moles hydrogen peroxide, right? And then, of course, we have to convert it, or sorry, multiply it with the dilution factor to get to know what is the concentration of it in the original 20 milliliter potassium permanganate solution. All right, so this is how we will be doing it. Question number 15 is the same thing, N equals N C into V. From there, we will find this is the 1:2 reaction as well. Sorry, this is 1:1 reaction anyway. It's 1:1 reaction, so you don't have to bother much, just number of moles, you have to find it. So basically, this is it. Any questions so far from this among 15 questions? No question? All right. So this thing, yeah. No questions so far, good. So this thing, actually, this is the same thing that we have just now seen in the self-testing question, is just elaboration in a way. Okay, so please go through it and just mind it that the test during the mid-sem, it will be in this format. It will be like this. Of course, it will be the multiple choice question, and also like this, you have to write it, right? You just don't write, okay, X or sodium hydroxide, right? Maybe. So calculate the average volume in milliliter concordant only in potassium. So you just write that average volumes 5. No, you will not get marks in this way. You have to write that the titer, just for example, yeah, titer is sodium hydroxide, or the identity of the compound is X, or 5 milliliter was required. In that way, you just don't write, don't just try to cut it short and get a always shortcut way. Shortcut way will not always give you marks. Okay. So yeah, you will be, a question will be there, and then you can answer the question. So the same thing, actually, what is the oxidation reduction is happening, which one is oxidant, which reductant, all those things. And yeah, this is the thing, actually, we have done it yesterday in the class lab. So yep. I think this pretty much I have covered. So is there any question so far? No questions. So I will see you day after tomorrow. No, sorry, on Tuesday, right? Tuesday, I'll see you during the lecture class, 4 to 6 p.m. And then have a nice weekend.